Time was, the data moved in batches, often overnight. Today, the information flows constantly, across the web and through traditional data centers. How do innovators harness this deluge? With modern data pipelines.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Your host here, Eric Kavanagh, and what an all-star cast we have for you today, folks. I'm really excited to talk about one of the hottest topics in our business. It's been evolving for the last 5 or 7 years or so, and now I think it really has reached fruition, at least the first stage, if you will, of fruition. Things are going very fast in the last half decade. It's kind of bewildering what's going on now. We're going to talk about modern data pipelines fueling the information economy. We've got Justin Mullen from Data Ops Live, David Mariani from Atscale, Cameron Turner from Kit and Carla, and Sean Anderson from StreamSets, all queued up to talk about data pipelines. So what are these things? Well, in the data management world, in the world of data warehousing, which is where I cut my teeth, gosh, 20 years ago, promoting this stuff, business intelligence, etc., ETL ruled the day. ETL stands for extract, transform, load. You would extract data out of a source system, transform it into some format that is acceptable for your end target, for the schema of your warehouse, for example, and you'd load it in there. And you do all these batch files, like I'll hit all these batch windows all day long, every day. And I remember quite literally 13 years ago in like the first year of DM radio, when I was still somewhat green, if you will, I remember thinking to myself, all this ETL, this madness has got to stop, because there was no orchestration really beyond just getting the job done. And over time, you would add more ETL batch windows and more and more and more. And then you didn't even know, are we moving the same data again? Are we overwriting good data with bad? And there was just no visibility. And it's also very expensive and it's brittle. And way back when, 20 years ago, well, lots of things were different. Processors were much slower, pipes were much thinner, storage was expensive. And so these were all constraints that drove the design of the products at the time, if you will, like the data warehouses of old. But they were very expensive. They took a long time to stand up. And then lots of things happened in our industry. The open source movement really took off with Hadoop. And even though Hadoop has kind of been folded now into some future-oriented solutions, it's still out there. It's not really going away. But we learned a lot of lessons in those years about distributed computing, about parallel processing, about being able to grab huge amounts of data, bringing the analytics to the data. All this cool stuff happened. And then, of course, you had something called Snowflake, with one of the biggest tech IPOs ever, as I recall. And it really was a clarion call to the industry that data warehousing is alive and well. And the folks at Snowflake did some really clever stuff, like separating compute from storage. That's kind of a big deal. But now the companies on this call today are all doing fascinating stuff. I mean, really. So I'll start off with Justin Mullen from Data Ops Live. Justin, tell us a bit about yourself and your company, Data Ops, and what you're doing in the space of data pipelines.
Yeah, thanks for having us on, Eric. Been watching this for a long time, so delighted to be on. So I've been in data analytics for about 30 years now in different guises. Spent the first 10 years in sort of IT systems analytics, a lot around help desks and monitoring of networks. And then next 10 years in sort of workflow and BPM analytics. The last 10 years, I suppose, just proper analytics, hardcore. Big data, as it was called for a while, the Hadoop space that you referenced for a while. So the last 10 years, I've been CEO of a company in the UK called Datalytics, which is a specialist firm delivering services. And we were the first partner of Snowflake, actually, in EMEA, way back in 2017. So we built that up, worked with lots and lots of organizations, hundreds of deployments. And then last year we sold it, and we took some of the software that we've been developing for the last 2.5 years called DataOps.live, and we launched that, our DataOps for Snowflake platform. And we co-authored DataOps for Dummies and True DataOps, the philosophy that's sort of building on top of the DataOps manifesto that came out a while back. I suppose from a company perspective at DataOps.live, the main things that we want to talk about and that we're focused on is really changing the focus in terms of treating data more like a product rather than a project. And what that means in terms of agility and governance and the way in which we embed automated testing and have to embed automated testing into every element of a data pipeline to be to treat the product and every refresh of that product as a new version of our product. And secondly, then as a result of that, how do we build and test and deploy those data products in the same way we built software products for the last 30 years? Now, do we bring those truest principles into that? So.
Yeah, and I think this is fascinating. You've got something you call a declarative data pipeline for Snowflake. And just to explain to our audience, declarative programming is really fascinating stuff. It declares the end state. You tell the software what you want it to be when it grows up, I guess, and then it'll figure out how to get there. So it's a very different approach than imperative programming, where you say, line 10, do this, line 20, do that, line 30, do this, line 40, do that. You leave it much more open, which is very interesting, but it's very good in terms of keeping those connections live, right? Because you'll build these data pipelines, data flows through them, is transformed, is enriched, for example. We'll talk about that later, I think, with Cameron Turner, and it gets to the end and you persist it in some schema in your online, your cloud data warehouse, or even your on-prem data warehouse, et cetera. But what you've done is kind of turn that all around, right? So it used to be this sort of manual effort of loading this batch, loading that batch, but you do all that magic in the pipeline, in the code. So you're mimicking what we learned in DevOps, right, with developer operations, but you're doing that in data ops. Can you explain how that works?
Yeah, sure. And it comes from that background of treating the end product as a product. So just think about just something as simple as the dashboard or the share of data that you're providing to someone, and thinking about that as an end product. Then you've got to think about everything else that we've built in the software world for the last 20 years in terms of how to build the automated pipelines around the development, the automated deployment of those products, the automated testing, the monitoring, everything around it, all of the cycle management that goes into it. So, we should never again really be talking about building data warehouses. We should be talking about building data products. And the warehouses and the data platforms and everything are just the things that we run them on. But when you think about it that way, and then you think about it from the perspective of, okay, what do I need if I'm going to treat it as a product? What do I need to be able to build and deploy and test this stuff in the same way that we did in software? You need core things. You need to focus on the developer experience. You need to have a code repository behind it. You need to have a collaborative experience for developers to develop in parallel and to develop more agilely and things like that. You need the orchestration to run the pipelines and to move the data through. But then coming to the key thing that you mentioned, it's the environment management. How do you build the environments in the first place? And how do you maybe step one step away and remove all of your code and your logic and move it into your Git repository and just treat your data platform like a very intelligent data engine? If you think about the software world, if you think about eBay, if you ask it what the source of truth is of the eBay system, no one's going to point you at the web servers, or Netflix, no one's going to point you at the video transcoding servers. They're going to point you at the code and the logic repository that sits around that they then use to project that and to create those new instances. And so in the data world, we've got a slightly bigger challenge because we carry state, and sometimes terabytes and petabytes of state that we have to manage and we have to deal with. But it's similarly, how do you then take that and project that onto your Snowflake data platform to build it? So not just building the tables and the views, but building the rows and the grants and the stages and all of the other objects that sort of fit into that whole environment. And when it comes to building that, you've got to say, right, what way does the software world do it? What way does the cloud world do it? Will it do it in a declarative fashion? No one says, do this, then do that, then do the other in that sort of imperative way. They describe the environment, they describe it in a file, they describe YAML file is what we use. And then you deploy that to a declarative engine, and the declarative engine's sole job is to say, right, what is the target that I'm looking at? What is the declaration of what it should be like? What are the differences between the two? And therefore, what imperative statements do I need to run to make the target look like the declaration that's being sent out? And that's sort of the key element behind it. So that's sort of what we've we've done in terms of the work that we've been doing around building that declarative engine, that Snowflake object lifecycle engine for the Snowflake platform.
I just love that stuff. I think it's brilliant. I mean, I was talking to a friend of mine who does a lot of real world work in this space, and he's like, oh my goodness, that just turned the entire industry inside out. Like he worked with big banks, and we spent years loading batch by batch by batch, and that's how you did it. But the world has changed dramatically. We'll stick around for the roundtables. Let's bring in David Mariani from Atscale, another company I've been following for, I'm afraid to say how long, for a number of years. But you guys are doing some really interesting stuff too. Tell us about what you're doing and how you're fueling the information economy.
Thanks, Eric. Appreciate it. Thanks for inviting me on the show. So I've been a data guy, just like Justin, my whole career. But really, the idea for Atscale really came out of my work at Yahoo. So in the heyday of Yahoo, we were an outlier when it came to big data. So much so that we invented Hadoop because we were breaking Oracle. And so I was responsible for analytics. And so I had all these data hungry consumers. We had Atscale Labs, which is all our data scientists. And of course I had 13,000 business analysts all out there trying to run advertising and to draw people to our websites so we could monetize them. And they all needed data. And the data we were collecting was massive and still is massive at the time. And we invented Hadoop so we could collect it, store it all in one place. And the problem was sort of that last mile, was connecting that data that we were collecting, which was so rich, and making it consumable by our data scientists and our business analysts, except that, it wasn't consumable, right? So all it was a big mass of data, and, requiring the business to actually do their own data engineering to make it work didn't work well. So I love what Justin said with data as a product. I really believe in that. For me, I wanted to connect that last mile of once the data did land in a location, how do we then make it business ready, decision ready? And how do we make it so that everybody in the organization can become a data analyst, can make a decision? And so I started Atscale really to create a semantic layer that would connect people, data scientists and analysts, to the data wherever it lay. And so no ingestion in terms of creating another analytical engine. Use the great technology that's out there, including Snowflake and BigQuery and Redshift and Synapse and the like. But connect that data and make it business ready through a semantic layer. So that means that allowing people to consume with Excel, with a live connection, with Power BI, with Tableau, with a Jupyter notebook, without having to understand data structures or how to write SQL. So just like Justin, you talk about data as a product. I love that. I also say, and some of our best clients, our customers, they got rid of the data analyst job title, because their goal is to have everybody be a data analyst. And to really realize that vision,
that's clever.
You have to allow everybody to access and be able to be productive with data, which means you can't make them have to write SQL. It's much easier to teach a business expert how to use data to make decisions than to teach a data analyst or a data engineer about the business. Yeah. So that's really our whole point, is make everybody a data analyst. Forget about making data only accessible by experts. And that means allowing them to consume the way that they're comfortable consuming, but allow them to do it with consistency and governance and performance.
And that's all great. That's fantastic stuff, I have to say. And if you step back and think about how we got here, we've learned a lot of lessons along the way, and automation is such a huge part of that. Justin referenced automation of testing, for example, and now we have the capacity to do it, right? I mean, 20 years ago, arguably, we didn't really have the capacity to do that. But I did love your comment about how you were breaking Oracle. And David, I remember in the aughts, in the 2000s, there was an exodus from Yahoo, and all these incredibly smart people went out and they all started companies. There were like 20 or 25 companies, and probably half of them are still around, but they all saw some opportunity, and they learned from the lessons at Yahoo, and now they went out and built that next generation. And we're now seeing the next generation of folks who are leaving Google and Facebook and LinkedIn and these other places where it's so specialized, but what's so cool is they all have the same vision, which is enabling the business to use data for decision making, right, David?
Yeah, you know, I love that. So we call it the Yahoo Mafia, and there's a lot of mafias out there. I know that, but you know what? I think what you're seeing there, Eric, is like we had to. The scale was unique to us at the time, and so but what I saw and a lot of my fellow Yahoo saw was that like this was the next wave. So while Yahoo was an outlier at the time, everybody was going to catch up to that when it came to how important data was and collecting those large amounts of data. So I think you're right that you know the people that were at those organizations that were outliers saw the future or had a head start on everybody else, which is why a lot of us went out and started companies because we walked in the shoes, we lived the pain, and we knew that others were going to be encountering that pain real soon.
Yeah, well, you also mentioned something else that's really important that I touched on, which is leaving the data where it is. You're starting to see this now. Databricks is talking about this. Other companies are talking about this architecture, which is very clever, where you leave the data where it is, let's say in S3, for example, and you build this transactional layer on top of it. Like, is it Hudi or is it Delta Lake or whatever it is? There are lots of different options, but it's the same principle. And I think it's very clever. And again, we can do this stuff now. You could not have done this effectively 20 years ago, but you have to stay up with the times. And you know, the companies that are leveraging technologies that you folks deliver, they're ahead of the game, and they're going to win. It seems to me. What do you think, David?
Yeah, you know, Eric, it's like it's a lot of times there's people who say, well, it has to be ETL or ELT, or it has to be data virtualization. And the answer is it's both. And there are use cases for both types of data integration technologies. And this is a great talk because it gives us the ability to really say, hey, you know what, you need a portfolio of ways of getting data from point A to point B. But if you can avoid moving data from point A to point B, God bless it, go for it. But sometimes you can't avoid it.
If you're out there wondering, what is that music? I love that music. That's Reel 10 by The Plugs. It's from the soundtrack of Repo Man. Look it up. One of the best, and the songs in that album are just absolutely fantastic. The Plugs are great. Anyway, we're talking all about data pipelines, modern data pipelines. Our next guest knows a lot about that. Sean Anderson from StreamSets is on the line. And Sean, you guys were one of the first vendors that I came across that had really taken this whole game to the next level. Because it's like I sit back and I watch, and like there's ODBC and JDBC and all this stuff, and that was like the only way to get data in for like since the dawn of time was ODB, JDBC. I know they're actually the guys who wrote that code. George Chow used to work over at that company, Simba, a number of years ago. But you really saw what was coming and built out this platform for just massive data ingest and massive data management. Tell us a bit about StreamSets and what you're doing in the pipeline space.
Yeah, Eric, thanks for having me on, and sorry to break your streak of having this is some of the brightest minds in data engineering.
No self-deprecation allowed.
So sorry, I know it was a long streak, but I'll congratulate you on it. So great to be here with this group of people. I, similar to David, started out my career in the genesis of Hadoop, you know, launching data products for Rackspace and eventually joining Cloudera kind of, you know, through their kind of triumphant rise. So one of the things that I saw at Cloudera was, you know, we were building out a great data platform. Customers wanted to do things like machine learning and data science. However, you know, one of the biggest struggles ended up being, how do I get data into this thing, right? I've got this data lake now. How do I get data into it? And you had some perfunctory tools, you know, Uzi, Scoop, that were part of the open source ecosystem. But a lot of ETL developers, a lot of people that worked with data were kind of more used to these kind of visual tools. So that's when I encountered StreamSets and really started to understand the importance of the pipelines getting data in there. And so I think you said it in your intro. You said, you know, what pipelines didn't used to be cool. So now why are they cool, right? And I think The answer to that is pretty much twofold. One, the original data pipeline was fairly static, right? So everything was on-prem. You would build, source and destination. The sources and destinations didn't really change. Really, the fundamental structure of the data never changed, right? Because you would set the schema at the organization level, and all of that was fairly static. The data pipeline never really broke. It fed the dashboard until something happened to where the business requirements changed, right? So the data pipelining used to be kind of more necessary, right? Now what we're seeing is an explosion of sources that companies want to interface with. So now they not only want that relational data, they want clickstream data, they want social data, they want streaming data that's cloud native, right? So the amount of sources that the company's hungry for is expanding. And at the same time, usually the investment in data science and analytics and machine learning is increasing as well. So people are hiring quants, they're hiring citizen data scientists, they're hiring data scientists in every faction of the business, one for finance, one for product, and all over the place. But what generally doesn't scale to that same degree is the data engineering, the data pipelining, right? So now we've entered into an era where data pipelining really needs to be not only a continuous effort. We can't just build a pipeline and set it, forget it. We need to upgrade it over time. As we migrate to cloud platforms, we have to adjust that pipeline. And the pipeline needs to be decoupled in a way that allows it to be portable across those different use cases and allows the user to evolve with that over time. So now we're seeing this entrance of this data ops concept, and we're heavily aligned on that as well. In fact, we're doing our data ops summit this year. And I think Gartner put it best many years ago when it entered the hype cycle by saying that data ops is people, process, and technology. So the companies that we interface with, large pharmaceutical companies like GlaxoSmithKline, big oil and gas companies like Shell, they're operating millions of pipelines, right? So a pipeline may not be sexy if it's just a pipeline in your home, but if you think about somebody who's working in an apartment building or a huge hotel complex, keeping all of those pipelines running, understanding, when they're going to break, what's happening with them, that whole operations part of the picture is now really becoming the tricky part. The development, is a problem that I feel like has been really well solved for. But how do you actually operationalize that? How do you scale that and operate, to the order of magnitude that some of these bigger people are seeing?
And you've got a concept which I love called data drift, right? And then in the older data warehousing world, you have slowly changing dimensions, for example. Can you talk about what data drift is, what it means, and why it's important to stay on top of?
Yeah, absolutely. So data drift is a concept that's fairly well known to everybody who works with data. And they might see different manifestations of this, but realistically at the ground level, data drift is the unexpected and unending changes that happens when data transverses multiple different systems. So as it goes in your data warehouse, as it goes through your Hadoop cluster, as it's conformed from raw to conform, these things materialize, and they materialize themselves in three discrete ways. The first is the structure of the data. So as data goes in different systems, you might see a different row or a different column appear, right? And if your systems are based on schema or based on that structure, it can really cause calamity, right? The second way is the semantic nature of the data. So the meaning of the data over time changes. So you might have, a certain way to represent things like time and date in some systems, or an IP for a network in others. And that meaning changes, it evolves over time. And as you start to aggregate different systems together, that becomes really problematic. And the last, which I think is the more prolific that's actually happening right now, is called infrastructure drift. And with infrastructure drift, that's basically when the source or destination gets upgraded. So say I'm doing Oracle CDC to my Snowflake, which I think was mentioned on here. Every time I upgrade my Oracle environment, every time Snowflake rolls out a new patch, with traditional data pipelines, that would break the data pipeline, right? And so this infrastructure drift is happening, and it's also happening strategically. You have your CEO that goes to dinner with somebody at Google, and suddenly you're no longer at AWS, you're on Google, right? So the ability to kind of deal with these changes, ongoing changes to the platform, is definitely not making this data engineer who has this huge backlog of projects, definitely not making their life any easier.
That's a really good point, because when you change the foundation, guess what? Other stuff is going to break, and it's very difficult. So you got to kind of get back to that declarative conversation that Justin was talking about. So you're also addressing this by focusing on data drift and really allowing organizations to manage data at a different scale than they've ever organized data around before. Isn't that right?
Yeah, absolutely, that's key. And incorporating those key tenets of data ops, right? So they can they do it in a continuous way that allows, a single data engineer to operate hundreds of pipelines successfully.
Yeah, well, that's the key. I'll tell you what. So let's get our last guest in. Cameron Turner has dialed in from Ken and Carla. Tell us a bit about what you're doing. So you're on the client side. We've had 3 vendors, and now we got one of the folks who's charged with actually getting all that stuff done. So lucky you. So Cameron, tell us a bit about yourself and what you're doing in the data pipeline space.
Hey, Eric. Good afternoon. Yeah, Cameron Turner from Ken and Carta. And the comments so far have been fabulous. So much of it is aligned with what we see. Ken and Carta is a global consulting firm. We service the Global 1000 set, and across a lot of different verticals. So one of the fun parts of my job is to get to see this problem, data pipelines, from a lot of different angles and a lot of different industries. My prior life was running the global data pipelines for Microsoft's telemetry team. So if you've ever opted in to send your error reports or your blue screen of death data back to Microsoft, that came into my team, as well as the joy of putting in a 5x5 product key in order to activate your software. That was ours too. So back in those days, things were very different. A lot of the comments that the other guests have, I think, are very much aligned. We have a lot more extensibility, a lot more acceleration into scenarios that weren't possible previously because you were spent so much time doing custom software development in order to manage your data pipelines. I think, for us at Ken and Carta, we're laser focused obviously on generating client value, on customer value. And what we're seeing, really in the last 2 years, I would say more than before, is an expectation. People really saw data and AI as a differentiator, as a competitive advantage, and more, both for B2B and for B2C, it's being seen as an expectation. So as an example, as a consumer, if you call into a call center with a support issue and you're registered and you've done all the things and you provide data, maybe through an automated call to provide data, and then you're asked to repeat your account number, or the concept of having an account number at all, given that you have caller ID. I mean, these are things that as consumers, we're starting to see, why do I have to sort of own all of that integration? There's an expectation that there's integration.
Yeah, that's right. The world is not static. It's very dynamic. And to a point made earlier, I think it was Sean who said the earlier data pipelines were very static. And that's just not going to work these days. You can't have that kind of solution because it's going to break and then you're not going to use it. And there's something to be said for patience and lack thereof, and for the criticality of immediacy and of demonstrating value and getting the business users involved. Because let's face it, people don't like to change, right? They want good stuff. There are certain things they want to change, but if you put change upon them, that doesn't usually go so well. So it's important to be able to evangelize what you're doing, but then also take the necessary steps to start getting things done. And to your point, Cameron, now you can do that in days sometimes, or weeks instead of months or years. That's a completely different dynamic, right?
I think that's something that we're seeing for sure in automated machine learning, the ability for systems to relearn themselves atop data stacks. I agree that generally organizational change into a data-driven culture can be very challenging, but something that we really owe to the agile process, I think, on the data side, is that ability to iterate. That we're not locked into 3-year product cycles anymore. We have a capability to continuously improve not just the user experience and the products themselves, but also all of the plumbing that's going on underneath them in order to enable that. A critical piece of that, I believe, is on the enrichment side. As we standardize on the algorithms and the data science side of things, it really comes down to the data. What signal is there? What signal is missing? And then how can we go out and get it? And so we see a lot of engagements where increasingly we're pulling in operations data alongside customer data, telemetry, finance data, CSAT, NPS scores. All those things can go into that process that will make prediction better and give you a fuller understanding of what's going on and deliver new value.
Big thanks to all of our guests today: Justin Mullen, Data Ops; Sean Anderson, Stream Sets; Cameron Turner, Kit and Carla; and David Mariani of Atscale. Look these folks up online. Thank you so much, folks.